In this video, we'll show 3 ways of observing control points that allow you to move the instrument during a survey. Firstly, let's look at the start-stop method. Press the control button to start. This informs the system that you're measuring control points. Align the instrument telescope with one of the control points using the mouse and press Start Capture. The survey instrument will lock on and hold the prism until the prism is moved. Move the prism off and back on the control magnet to start the measurement. Then move the prism to the next control point magnet. The computer screen shows the user when the point has been captured. The prism is tracked constantly after the Start Capture button is pressed. When the prism stops moving and is steady, the distance is measured, the angles rechecked, and the observation recorded. There is also an audio beep when the point is captured. The order of capture is not important. The start-stop method uses the prism ball and several of the PTFE-coated magnets found in your device set. You will always need a minimum of 4 control points. This set of points should have good shape and scale. For more information on shape and scale, please view the Move Instrument video too. After 4 controls have been captured, the automet system reviews the scale and shape. If acceptable, the control button turns green, indicating that you can move the instrument. Press the Move Instrument button and move the instrument. After pressing the Move Instrument button, the capture screen border changes to red and no other buttons are active. Align the instrument telescope with a start point. This can be different from the first setup. Press Start Capture and move to all of the control points and measure again from the new instrument position. In this video, we are not showing how to measure spool detail points, just focusing on control. The start-stop method should be used when the survey area is small. If the survey area is roughly 10 meters or more, then use the single point method. After 4 controls have been captured, the screen border turns green. Press the flashing Complete Move button. Now you will see the Move Quality Assurance information. See the Move Instrument video too for more information. Now you can finish your survey, capturing the spool detail points that you couldn't see from the first instrument position. Next is the single point method using a prism. The start-stop method requires you to move the prism ball between the control point magnets. This may take some time if the controls are far apart. The single point method requires a prism ball for each control point. When control points are far apart or in difficult to access areas, this method is much faster than the start-stop method because the telescope is aligned using the laptop mouse. Once aligned with a prism, press the single measure button and ensure that the prism measurement option is selected. Otherwise, a laser distance will be measured. Any prism ball control points measured incorrectly using the laser option will be invalid. Align the instrument telescope with each control point and capture them in any order. A typical survey would measure detail points such as flanges, planes, and circle fits. Any point can be measured at any time, as long as the name is correctly assigned. Once all the points have been measured, press the Move button to move the instrument. After moving the instrument, repeat the control points. Press the Complete Move button to continue the survey. Please contact ML Tech if you require more prisms. The single point laser method is similar to the single point method using prisms. The main difference is that the instrument's laser distance meter is used, rather than the infrared distance meter used to measure prisms. Each survey target must be sighted through the instrument telescope, which means this method takes longer to carry out than the prism ball method. This method is also slightly less accurate. However, it has the advantage of not requiring the use of prism balls. Another significant advantage is that a readily identifiable surface feature can be used on a highly visible but inaccessible surface, such as a ceiling. All three methods can, however, be used together. This control point can be seen from multiple setups, making it an extremely useful control point in a narrow corridor or other situations where the shape of the control points is an issue. Remember that control points should not be arranged in a line. The Move tab shows that the maximum residual for the move is higher than the previous control methods. This is because of the greater lack of accuracy with this method.